Let's talk about statistics, statistics. Let's talk about statistics and you. Welcome to the wonderful world of math, statistics style. We're going to do the empirical rule, part 2, talking about examples. Last time we talked about how 68% of the observations will be between one standard deviation below and one standard deviation above the mean. So that's mu minus sigma, one standard deviation below the mean, and mu plus sigma, one standard deviation above mu. If the observation's distribution curve is approximately bell-shaped or normal, that 95% of the observations will be between two standard deviations below and above. That 99.7% of observations will be within 3 standard deviations to either side of the mean. We were also able to fill in each of these individual non-overlapping regions. And this time we want to practice using this in a question. Now, one of the things that I forgot to say last time is that you can do this same empirical rule if you're working not just with a population but also with a sample. Do you guys remember what symbol we used for the sample mean? It wasn't Greek. It was an English letter with a bar over it. It was X bar. That's right. And what did we use for the sample standard deviation? The English letter S. So this, one standard deviation above, would be the mean plus one standard deviation, 1s, or s, x bar plus s, and one below, x bar minus s. And then you can figure out these x bar plus 2s, x bar plus 3s, etc. So, our first example. The mean weight of the adult male snow troll is 500 pounds, according to the 5th edition Dungeons & Dragons Player's Guide, with a standard deviation of 17.2 pounds, which I just made up. If the weights of trolls are normally distributed, or bell-shaped distribution, find the following. The range of weights of the middle 68% of adult male snow trolls. This is something that we can do with the empirical rule. Look at this picture, right? We've got population data here. So this is, there we go, population data. The middle 68%, notice how this 68% is right or centered around the middle? This question, the range of values, is asking how low does it go and how high does it go? The values that contain the middle 68%. So what are these values? Our first question is just asking what is mu minus sigma and mu plus sigma, but we have to know the empirical rule well enough to figure that out. So mu was given to us as 500 pounds. Sigma was given to us also as 17.2 pounds. The things that were asked for, the lowest value and the biggest value that border this middle 68% are going to be mu minus sigma and mu plus sigma. So find these real fast. So we've got these two things, and for which we should make sentences for our answer. This is a word problem after all. And this is what our sentence should look like as an answer. The middle 68% of adult male snow troll weights are between 482.8 pounds and 517.2 pounds. So number 2, the percentage of adult male snow trolls weighing between 482.8 pounds and 534.4 pounds. In the beginning, when we're just starting out and we're just learning the empirical rule, there's really only one resource for this. As we learn how to do this later, we'll get better at this and be able to do this for any two weights. But for now, with just the empirical rule to work with, we essentially want to figure out how to label this with numbers from the problem. So what is mu for this problem? Mu was 500, right? What is mu plus sigma? Well, mu plus sigma is 500 plus the standard deviation, sigma, 17.2. Mu plus sigma is going to be 500 plus 17.2. Notice that that was one of the numbers we found last time. And mu minus sigma. This is going to be the other answer we found last time, 482.8. Notice that these are the two boundaries of that middle 68%. So I want you guys to find these other unfilled in numbers. Are you ready? Okay, so let's check, see if you got them right. This is what we want our graph to look like. When we're working on a problem like this is the picture we should be drawing and labeling, okay? So what percentage of adult male snow trolls weighed between 482.8 and 534.4 pounds? In the context of the empirical rule, we have to assume, more or less, that those are numbers that we can work with, that they have to be of the form mu plus or minus some amount of sigmas, some whole number, integer number of standard deviations away from the mean. So you go ahead and you find those things, and you look, here's one of them, and here's the other one. We're looking for the percentage of snow trolls between here and here, right? So what does that correspond to? That corresponds to this region, and this region, and this region, and this region, these four regions. So we want to add these things up to find the total area, to find the total percentage. You can start by adding 34 plus 34 plus 13.5 plus 2.35, and that'll cut it. But it's really helpful to know that the middle two add up to 68%. This plus this adds up to 68%. So you take the 68% in the middle plus this plus this. So we add up these areas of the four regions, and we're going to get 83.85% of adult male snow trolls weighed between 482.8 pounds and 534.4 pounds. So there's our nice sentence. And again, when you're faced with a problem like this, the very first thing that you should do, if all of your tools are the empirical rule, first you have to make sure that it's normally distributed, right? Bell-shaped distribution. That you just start looking for mu plus sigma, and mu plus sigma 2, and mu plus sigma 2, sorry, 2 sigma, and mu plus 3 sigma. And then mu sub minus sigma, and mu sub minus 2 sigma, and mu sub minus 3 sigma. You start looking for those numbers, and they should turn out to be, some of them should turn out to be the numbers that you were given. If they weren't, well, then you should ask your teacher, or maybe you're further along in the course, and you have some bigger tools. But at the beginning, well, in the middle of the first third, these numbers should be some of these numbers down here. And if they're not, ask your teacher. Okay, question 3. The mean weight of the adult male snow troll is 500 pounds with a standard deviation of 17.2 pounds. If the distribution is approximately normal / bell-shaped, find the following. The percentage of adult male snow trolls weighing less than 465.6 pounds. Again, with just the empirical rule to work with, we have to assume that this number is going to be one of the mu plus or minus sigmas, because we don't have anything else to work with. Later we will, but now we don't. So, if you haven't yet, and you should have, because we did it once already in this video, you should be finding those, figuring out how to label this curve. So, you should probably practice doing it again. 3, 2, 1, bow! This is what we're looking for. So, we said the percentage of snow trolls that weigh less than this number, that happens to be mu minus 2 sigma, right? So what is the percentage of snow trolls that weigh less than this? That's going to be the sum of these two regions. These trolls and these trolls all weigh less than 465.6. We need these regions. So what is the sum of the two areas that I just grayed out? Well, 0.15, 0.15, and 2.35. When we add up those two areas, we're going to get 2.5. 2.5%. That's it. So there's our answer in a nice sentence. And we can move on to question 4. Question 4. What is the percentage of adult male snow trolls weighing less than 534.4 pounds? So what I want you to do is go back to the picture and look at it and figure out which regions are included in this weighing less than 534.4 pounds. Add them up and tell me the percentage. So, try it. We'll check back. And 3, 2, 1. Here's your chance. If you did what I admit I asked you to do more directly than I intended, you should have looked at the graph. You should have said, here's the mean. Here is 517.2, and here is 534.4. And you've got mu minus sigma, mu minus 2 sigma, mu minus 3 sigma, and everything less than this is going to be 1, 2, 3, 4, 5 regions altogether. You may have added each region individually, which would have taken a little while, and is not a bad thing to do, but there are faster ways to do this. Notice that this is definitely included in the purple, and this here is the middle 95%, according to the empirical rule. Between 2 standard deviations above and 2 standard deviations below is already 95.7%. The other thing is that in the previous problem, we just found that this from here to here was, you remember, 2.5% from the previous problem. So this is from the empirical rule, and this is from the previous problem. All we really have to do is add those two together. Doing it each individual region at a time, or using the empirical rule to do the middle 95% altogether, and then adding up the two in the tails, the single tail, or using the previous problem and the empirical rule together and skipping straight to 97.5%. Whoosh! This is our answer, and these are 2 to 3 ways to do it. And there's a nice sentence for our answer. Alrighty, campers, time for example 2. Jarvis has a cheese farm. See cheese picture. Below are the milk production rates for his cows on a day in the month of Cheesevember last year in gallons. You'll notice that there are 1, 2, 3, 4, 5 rows of 1, 2, 3, 4, 5, 6 columns, meaning there are 30 cows on Jarvis's cheese farm. Assuming now that the milk output of Jarvis's cows is approximately normally distributed, it is, I checked, also known as the bell-shaped distribution curve, normal, bell-shaped. What percentage of cows produced between 7.52 gallons and 8.48 gallons of milk? According to the empirical rule, 99.7% of cows produced milk between what 2 numbers? Approximately what percent of cows gave more than 8.24 gallons? These are the 3 questions I want you to ask using this data. You'll notice that one thing I didn't give you that we had last time was the mean and the standard deviation for which to label all of the important lines on the horizontal axis for our bell-shaped distribution curve. You'll also notice that Jarvis has way more than 30 cows, right? I mean, sorry, he has 30 cows. He has way more than 1 day of cow production. So this is a sample. 1 day. This is a sample, which means you won't be looking at mu and sigma. You will be looking at x bar and s when you find them. How do you find them? Ho 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 ho. If you don't remember how to use your calculator to find the standard deviation and probably also, the mean of a sample like this, then look it up. Check it in the book. This is my strongest recommendation. A second, you could probably find something on the interwebs to help you with that. So find x bar, the mean, and find s, lowercase s, the sample standard deviation, and use it to help you answer these 3 questions. We're going to give you a minute. Pause this and go work on it and come back and you can check it. Okay? Thanks. Checking your work in 5, 4, 3, 2, 1. The mean and the sample standard deviation. I gave you 4 here just so you can check your work, but they should have rounded to 2 decimal places. That's our standard 2 decimal places for x's and s's. we'll use 4 for probabilities and proportions and so forth, but 2 for everything else. So here's our data, here's our x and our s. So we're going to take these and we're going to answer our questions. If you hadn't got this far, or if you got them wrong, here's your chance to pause it again before we go on to the next hint. 3, 2, we don't say 2 or 1. Well, why not? We just don't. Okay? So here we go. We've got this. This is our next hint. If you didn't do this, fill in all of the things on this graph, then you should. This is the sample version. Go ahead and fill in what is x bar, what is x bar plus s. Fill in all of those things. And 3, 2, 1, let's check if we did it right. This is what we should get, and of course we also need to be able to fill in these percentages, right? 34 in each of these regions, 13.5 each of these regions. If you haven't filled it in, now's your chance. 3, 2, 1, let's jam. Boom. So this is what we need to do to answer our questions. If you have not answered the questions, now's your last chance to answer question number 1. Boom, 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 boom. What percent of cows produce between 7.52 gallons and 8.48 gallons? Well, look, those two numbers are right here at 2 standard deviations away to either side. The empirical rule said that 95% of observations are within 2 standard deviations of the mean. That is one of the straightforward parts of the empirical rule, so this is 95% right away. Number 2, according to the empirical rule, 99.7% of cows' milk production was between what two values? The empirical rule said that 99.7% of values were within 3 standard deviations. So this, the third part of the empirical rule, says it's between here and here. There we go. 99.7% of cows' milk production was between 7.28 gallons and 8.72 gallons. And number 3, approximately what percent of cows give more than 8.24 gallons of milk? You find 8.24 gallons of milk, and these are the cows that gave more than that. This plus this plus this. 16%. There you have it, friends. 2 examples, one sample, one population, of using the empirical rule for stuff, you know. So the end of that brings us to the constellation of the day, Cetus, the sea monster. Sometimes nowadays it's called the whale. And here, this is roughly what the constellation looks like. This has been a Badger Bear production of the wonderful world of math.